We now know that a compressor's threshold determines the point at which the compressor activates, but how much the signal is actually compressed is controlled by a parameter called ratio. A compressor's ratio control determines how much any signal over the threshold is attenuated, and is generally expressed as a larger number over 1. For example, 4:1. Many times compressors will express the threshold and ratio relationship using an XY graph called a transfer curve. A transfer curve graph plots the signal's input into the compressor on the x-axis and the signal's output on the y-axis, so you can easily trace different scenarios just by following the line. The kink in the line, called the knee, is the point at which the compressor's response becomes nonlinear. That is to say, the input and the output do not match because the compressor is now reducing the gain of any signals over the threshold by the amount defined by the ratio. A ratio of 1:1 means no compression takes place, and lower ratios may be barely visible. Higher ratios create a more aggressive kink or even a horizontal output level line. The easiest way to wrap your head around ratio is to flip the number and treat it like a fraction. A ratio of 4:1 flipped into a fraction would be 1/4. So every signal that passes the threshold is reduced to a quarter of the original input level. Sound complicated? You get the hang of it fairly quickly after a few examples. Let's take a look at a simple input-output table where the threshold is -20 dBFS and the compressor's ratio is set to 2:1. With a threshold set at -20, an input signal at -25 does not breach the threshold, so no compression is applied. If the signal is increased to -10, that is 10 dBs over the threshold, at a ratio of 2:1, the overage of 10 dBs is halved to 5 dBs, so the output level is -15 dBFS. If the input level is increased even more to -5, the output level would be -12.5. Why? Because the input signal is 15 dBs over the threshold, and half of that is 7.5. Add the 7.5 to the -20 dBFS threshold value to get -12.5. A ratio of 2:1 is considered light compression. Increasing the ratio and lowering the threshold of the compressor will cause the compressor to attenuate the incoming signal even more. Compressors with ratios of 10:1 and higher provide much stronger compression and even go by a different name, limiters, which we'll be covering later in this course. If the graphs and ratio numbers I've shown you here have you shaking your head, don't worry. I rarely concern myself with the actual numbers while I'm working with the compressor and generally apply the compression by ear, using strategies that I'll explain later in the course. Now, let's move on to some other compression parameters.